Okay, hi, I'm Jeff, and I'm going to be talking to you today briefly about our integration efforts with HP Vertica and external analytics engines, and this is work with my colleagues Ray, Malu, Chiming, and May, who are here today, and we're at HP Vertica West. Okay, so at a high-level goal, we really want to extend Vertica's capabilities to add additional machine learning algorithms. So there's many machine learning specialized processing engines that offer libraries, such as MLlib, graph libraries, and we want to be able to have Vertica reach out to those libraries and take advantage of those specialized engines. Secondly, we like to keep the database as the enterprise quality data management system. Okay, Vertica is an enterprise class database, offers robust, fast query processing, also allows you to do data preparation in SQL, which is very common for machine learning tasks ahead of time. Then we'd like to let data scientists use the tools that they're familiar with. So by reaching out to these engines, they can continue to use their favorite statistical tools, such as R or something like that, and they can do the work in that engine. And what we'd like to do is export the database data from Vertica directly to their engines so they can do their work there. And then once they're done training and creating their models, we want to make it easy for them to deploy the model back inside the database. So push the model back in the database, and then inside the database, we can do in-database scoring of database data. So briefly, there's three current efforts right now at HP Vertica. So we're integrating with Distributed R, which is an HP Labs project that's open source and it's available. It's a machine learning platform. We're also looking at integration with Spark, also has machine learning and graph library algorithms. And integration with Caffe, which is a deep learning platform. So briefly, an end-to-end sort of analytics workflow pipeline would look something like this. We have the database HP Vertica on the left and the specialized engine Distributed R or Spark or say Caffe on the right. And the database will load and ingest the data. Then you might do data preparation in SQL. And then right there, we would like to export the data to the export to the external tool, where the data scientists can then build their models and train their models, evaluate their models, and then bring it back into the database where it can be deployed. And notice this keeps the sort of the exploratory analysis phase outside of the critical path of the database production query workload. Then when it gets back to the database, we deploy the models for in-database scoring. So this would be the model prediction function. So the challenges here, essentially, first is the data transfer problem. So we're going to transfer data from the database to distributed data structures, right? So there's a naive implementation of this can be very slow. We also want to consider handling data skew in the case of transferring, and we want to transfer a consistent view of the data as well. And then some other issues here are model deployment. So we like to make it easy to deploy the model back into the database. It should be simple, not a complicated process. Also, the model has been trained by an outside system, not Vertica itself, so it's a model built by a different system, so there's some challenges there. Also, models can be very large. So, for example, if we look at Distributed R, this looks like the pipeline I just showed you. We have a load, build, deploy, and then in-database prediction. So load is simply load your database data to a distributed array with the table and some parameters. Model is the model function there with some parameters, data X and Y. And then deploy model, as I said, we like to keep it simple. Something like this is deploy.model. This model will give it a name. And then for in-database prediction and scoring, you can simply write a SQL query, select using this particular predict function, my parameters, and my model from a particular table. So similarly, what this looks like in Spark, and this is ongoing work, load the data is a simple operation here as well. And training your data on the model. Similarly, deploy is a simple step. Right? So store the clusters. And then again, it's a simple SQL query to do in-database scoring, which is select from a particular model with your parameters and a model number. So what are some of the data transfer issues? First, you could consider some, say, 3 Vertica nodes on the left and some external engine nodes, same number of engine nodes on the right there. Maybe consider a locality preserving policy, so this is sort of best case one-to-one scenario. But in another case where you might have data skew, we might have a uniform distribution policy. So this is actually a Distributed R specific example where now each node is going to transfer its data to multiple other nodes in the distributed array. And that's going to handle data skew, as I mentioned. Okay, so some preliminary results just real quickly. If we look at data loading here, time in minutes on the y-axis, and then along the x is the different data sizes. And a basic R with ODBC data loader, this is for a 5-node cluster, can take quite a long time, this is over 10 minutes. And a distributed R version here, which is in red, is quite a bit faster. And that's an ongoing project. And this is the sort of preliminary results with a Spark data loader, also does pretty well. So for distributed R, it's open source, like I said, and there's the GitHub address. And for more information, there's a paper, Presto earlier, and a 2015 Sigma paper to appear. Thank you very much.